Okay, so just going to walk through a few screenshots of what it's like to operate in Hortonworks DataFlow powered by Apache Nifi. Just to give you a visual sense of what's happening, this is something which frankly is a lot more fun to just download on your desktop and try for yourself. What you're looking at here is a screenshot of Nifi running in a web browser. Any HTML5 friendly web browser should work well. The screen that we're looking here, you can think of that as a blank canvas. And that's essentially what happens when you start Nifi for the first time is you have this engine sitting there ready to do something, and now you can start to design the flow that you want. And so that's what we have shown here on this next slide. You select from the top left, you click and drag down into the graph where you want to add a component. And now you start the process of selecting which component you want to add. And so, for example, today there's about 90 processors in Apache Nifi that come out of the box. And what you can do is search based on their name or based on tags. And these are to do things like interact with databases, to get and push data perhaps, or to interact with HTTP or JMS or other open source projects like Kafka and Solr and so on. And once you've acquired data, you can do things like enrich it and make routing decisions and transform the content. Things like converting CSV to Avro or converting Avro to JSON. There's a whole range of kind of scenarios that you can walk through. There's also support for interacting with kind of legacy systems, like if you just have to pull files off of a file system, or if you want to store files somewhere, or say you want to set up an alerting flow, you can send emails. However, there's a whole range of these kind of Legos, if you will, that you can throw onto the chart, onto the flow and build. So we pick one of these processors for our flow. In this case, we want to grab the processor that interacts with Twitter. And so we've typed in Twitter. We see that we have this get Twitter processor, and so we click add. And now we can start configuring that processor. So it's on the graph, and now I want to give it some properties. When we do that, we're able to specify what type of Twitter endpoint we want to be, for example, any terms that we may want to filter on, a whole range of things that are specific to what that processor does. And so you adjust those parameters, and now you have this processor on the graph. It's ready to go. It can actually acquire data and start doing some processing on it. But the next thing that you want to do is deliver that data somewhere. And so in this case, we're going to put these tweets into HDFS. So we're going to drag and drop that processor icon again onto the graph and type in put or HDFS or any number of tags that will quickly get us there. And once we've done that, we can grab this put HDFS process and we can configure it. We can tell it where to find the configuration file for interacting with HDFS, directories that we may want to write to, how we want to handle certain conflicts, and a range of other kind of HDFS-specific tuning parameters. Once we've done that, now we have two processors on the graph, and now it's a matter of dragging a relationship from get Twitter to put HDFS. Just click and drag. When we do that, we now get to decide behavior of what happens on that connection. This is where we get to set things like prioritization. Let me go back. This is where we can set things like how we prioritize the data, whether we want back pressure to kick in. So let's say we're having trouble delivering to HDFS fast enough, and we want to stop pulling in the tweets, for example. Back pressure would automatically do that. If it hits some triggered threshold, then the previous processor would start slowing down. That causes a really nice kind of natural propagation all the way back to the source. So now we have this stuff wired up. We have our get processor or get Twitter processor, put HDFS. They're now connected, and we can go up to the top of the graph and just hit play. Or you could play individual components, whatever the case may be. You can do that. You can build it while the data is flowing as much as you like. And immediately the data starts flowing. The UI is giving you rolling 5-minute window of information about what's happening. Basically the past 5-minute window of what's happening. Statistics about how many bytes have been read, how many bytes have been written, how many objects in total are being dealt with. And this gives you really important information as an operator wanting to understand what's happening to my system at runtime, what's happening to my system in production, which parts of the flow are using the most resources. we're actually counting the bytes that are being read by the processor and written by the processor to the underlying repositories. That information is really valuable so that you can see where, what parts of the flow are consuming system resources. We're also tracking things like how many tasks are run, how many times do we give that processor a thread to execute, and when we do, how much wall clock time is being consumed to do that function. Really important information that if you're an operator allows you to understand what's happening to your system in production, or if you're a developer, it allows you to see and really fine-tune latency behavior as you pick different configuration settings. As I've mentioned a little bit here, you can already start to, or you can immediately start to dynamically adjust these properties. So you don't have to stop the entire flow or deploy an entirely new one. You can go to very fine-grained points of the flow and tweak configuration settings. You can even add new processors onto the graph and just click and drag the same relationship again. And now Nifi sends a copy of the data to the other processor as well. So you don't interfere with the existing, let's say, production flow. Now you want to start building a new one. This is really valuable because there's really nothing quite like production data to tell you whether or not you're on the right track. And we don't want to have to actually copy bits under the covers. And so this allows us to very efficiently do, high-scale processing. And that's something that we can talk about more as we go forward.